All right, let's just jump right in with a pretty wild idea. What if the whole field of physics isn't just a science, but actually operates like a religion? I know it sounds out there, but that's the argument from one physicist we're going to explore today. So here's the quote that really kicks this whole thing off. The author, who's a physicist, by the way, says, "We are as religious as they come, but the trick, the trade, is to make everyone think that we're not just believers, we're knowers. It's this deep system of belief that's at the very heart of the field, but it's presented as pure objective fact." So how on earth do they back up a claim like that? Well, the argument basically breaks down into three main parts. The author points to what they call a physicist's faith and says it's built on a few different kinds of belief. Beliefs in abstract ideas, beliefs in the sort of artificial lines we draw to make sense of things, and beliefs in the big accepted truths of the field. Now, just to be super clear, when the author says religion, they don't mean churches or deities or anything like that. They're talking about a system of core beliefs, these foundational ideas that are just accepted as true, and then everything else is built on top of them. So let's dig into that first set of beliefs they point to. Okay, so this first one is really interesting because it targets the most basic tools in a physicist's toolkit. The author's point is that some of the most fundamental concepts, the stuff they use every single day, are really at their core just undefined articles of faith.
So, what are we talking about here? What are these core ideas that physics is supposedly built on, but can't actually truly define?
You're not going to believe the first one. It starts with numbers. Yeah, just numbers. The absolute language of physics, right? But here's the shocking point the author makes. We believe in them, we use them for everything, but try to fundamentally define what a number is, and you can't. It's this foundational concept we just have to accept and move on.
And then you've got infinities. The infinitely large, the infinitely small. They're everywhere in theoretical physics. But again, the argument is the same. It's a concept we totally accept and use, but without a truly solid definition. It's almost like a convenient idea that we agree not to poke at too hard. And the third example here, continuity. The idea that you can just keep breaking things down smoothly, endlessly. I mean, this is the whole basis for calculus, which is pretty essential to physics. But once again, the author puts this into that same bucket, a belief that we can't quite nail down with a final, concrete definition. So when the author talks about a belief system, let's be clear what they mean. This isn't about worship or anything like that. It's about those foundational, unproven starting points, the axioms that we have to accept as true before we can even start to build our models of how reality works. All right, the next category of belief the author dives into is all about how physicists create distinctions, how we draw these, artificial lines to make sense of a universe that might not actually have those lines in it at all. Think about this. To do any experiment, you have to draw an imaginary line between your apparatus, your equipment, and the environment around it. But where does one really end and the other begin? At a molecular level? An atomic level? The author says this boundary is a totally artificial human invention. It's a belief we need to have just to get the science done. And this points to what the author sees as a pattern in physics, a kind of recurring habit. We create these separations because they're convenient for us, right? But then we conveniently forget about the consequences of forcing these artificial boundaries onto what is, in reality, a totally interconnected system. So here's how the author breaks down this whole modeling process, basically in 4 steps. First, you isolate a system. Second, you define its boundaries, like the line between the apparatus and the environment. Third, you create a model based on that isolated system. And then, and this is the crucial part, you basically ignore the fact that the boundaries you just drew were totally artificial in the first place. Okay, now we're getting to the real meat of physics itself. This last section looks at the core concepts that every single physicist learns. These are the theories presented as solid, established facts, but, you guessed it, the author reframes them as foundational articles of faith. Just look at this list. Quanta, quantum fields, action at a distance, particles, even the super famous second law of thermodynamics. I mean, these are the absolute cornerstones of modern physics, right? They're taught in every university. But the author puts every single one of them in the same category. They are powerful, incredibly useful ideas that we believe in, but ultimately they're human constructs we use to describe reality. They aren't reality itself. This is a really subtle but powerful point the author makes here. They argue that nature doesn't actually follow laws. Nature just does what it does. It behaves according to its own inherent properties. It's us, humans, who watch that behavior and then infer laws from it. So the belief here is that we mistake our human interpretation, the law, for the real thing. So where is this all going? After laying out all of these so-called beliefs, what's the final takeaway? Well, this brings us to the author's conclusion about the role of the scientific method in all of this. And here it is, the big punchline of the whole argument. We are religious people using the flawed scientific method as our shield. The claim is that physicists are operating from a core belief system, like religious people, and the scientific method is the shield that gives it all the appearance of pure objective knowledge. So, in the author's final take, the scientific method is way more than just a tool for discovery. It's actually a defense mechanism. It's what allows these believers to present themselves as knowers, and it reinforces their worldview as the one correct way of seeing things. And that really leaves us with a pretty fascinating question to chew on, doesn't it? I mean, whether you buy this whole argument about physics or not, it kind of forces you to ask, is some kind of belief, some set of unprovable starting points, is that a necessary part of any system we use to try and understand the world?